Hey, welcome to The Explainer. Today we are going on this incredible journey, tracing how AI went from just being really good at games to becoming a real partner in scientific discovery.
So, what if AI can make discoveries that humans just can't? You know that question? It's not science fiction anymore. It is happening right now, and we're going to break down exactly how.
All right, here's the plan. We'll start with the foundation, this idea of learning by reward. Then, we'll look at a huge evolutionary leap, AI as a coder. After that, we'll see the new toolkit that's created. And finally, we'll peek into the future and ask, what does it mean to have AI as a partner?
Okay, first up, the foundation. How does AI even learn to win? To really get where we're going, you got to understand where it all started. And that starting point is this core idea called reinforcement learning. So what is reinforcement learning, or RL? Well, think of it like this. An AI agent learns by doing. It tries things, gets rewards for good moves, and penalties for bad ones. It's basically trial and error on a massive scale, not just following instructions. And this idea, it's so central, so important, that its pioneers, Sutton and Andrew Barto, just won the 2024 Turing Award for it. That's literally the Nobel Prize of computing. A perfect example is AlphaEvolve learning chess. It's this simple but incredibly powerful loop. First, a neural net predicts what moves look good and its chances of winning. Then, it explores those paths, kind of looking into the future to see what might happen. And finally, it learns from the outcome, win, lose, or draw, and updates itself. By playing millions of games against itself, it went from zero knowledge to the best chess player on the planet in just a few hours. Wild.
But there was a catch, a big one. All this incredible power, this genius strategy, was locked away inside what we call a black box. The AI learned a policy, basically a giant set of numbers in a neural network, not a strategy that a human could actually read or understand. We knew it worked, but we didn't really know why. So that brings us to the next big step, the evolution. How do we open that black box? You see, this is the crucial question, right? How do we get from an AI that's a brilliant but totally silent partner to one that can actually show us its discoveries in a way we can understand and trust?
The huge leap forward was to crack that thing wide open. The whole goal shifted. Instead of an AI that just spits out a black box policy, the new goal was to have an AI that outputs actual human-readable code. Think about the difference. One is a black box that just knows the answer. The other is a white box that shows you the answer. It's something we can read, verify, and even learn from.
And this is where a system called AlphaEvolve comes in. It's basically Darwinian evolution, but for algorithms. It uses large language models in this amazing loop. It generates code to solve a problem, tests that code automatically to see how well it works, and then takes the best solutions, the fittest ones, to inspire the next generation of code. It just keeps iterating and improving.
And look, this is not just some research paper idea. This is happening for real, right now at Google. They're using AlphaEvolve to optimize huge real-world systems. We're talking about things like data center scheduling, speeding up how they train their Gemini AI models, and even rewriting the hardware code for their TPU chips to save power. It's cutting down tasks that used to take months into just a matter of days.
Now get this. One of the new scheduling codes from AlphaEvolve reclaims 0.7% of stranded compute resources across Google's entire server fleet. Now, I know what you're thinking. 0.7%? That doesn't sound like much. But you have to remember, at Google's scale, that tiny number is massive. We're talking about a huge amount of computing power and millions upon millions of dollars in savings. It's a real game changer.
But it's not just about saving money or making things more efficient. It's also pushing the absolute frontiers of science. AlphaEvolve was tested on over 50 open mathematical problems that have stumped humans for years. And in about 20% of them, it discovered brand new, provably better solutions than anything we'd ever found before.
Here's a perfect example to wrap your head around. It's called the kissing numbers problem. It's super complex, but basically the human record for a specific version of this problem was fitting 592 spheres together in 11 dimensions. AlphaEvolve came along and found a new way to do it, with 593 spheres, just one more. But that one more is everything. After years and years of human effort, the AI found a new path. That's power.
Okay, so this brings us to the application. AI can now generate solutions we can actually check and verify. What does that mean for scientists and engineers working in the lab today? Well, it means they're getting a whole new toolkit to play with. And in this new world, you're faced with a really interesting question. Does your research need a writing assistant, or does it need a full-on research engine? This choice is perfectly highlighted by two brand new tools that just showed up in January 2026, OpenAI's Prism and something called Cadence Web.
Let's break them down. On one hand, you have OpenAI Prism. Its main job is writing assistance. It does not do the research for you. You bring your completed analysis, and it helps you create a polished paper. On the other hand, Cadence Web is all about autonomous task execution. It does do the research. You give it your objective, and it gives you back the full report. Two totally different approaches.
So let's look closer at Prism. Think of it as the ultimate smart writing desk. It's a free, collaborative LaTeX editor powered by GPT 5.2. It brings together writing, editing, citations, literature searches, everything. It even has real-time co-authoring. The goal here is to completely streamline that final, often painful phase of research, writing the actual paper.
Cadence Web. Now that's a different beast entirely. It's an automated research engine. Its goal is to automate all the heavy lifting that comes before you even start writing. You give it an objective, and it just goes. It'll run statistical analyses, build machine learning models, create data visualizations, and even pull and verify sources from academic databases. By automating all that work that used to take weeks or months, it does more than just save time. It frees up researchers to ask bigger, bolder questions, and that could fundamentally speed up the pace of science itself. So let's talk about the future. Where do we go from here? When you put all of this together, it's pretty clear we're looking at a fundamental shift. The relationship between humans and AI in the lab is changing. It's becoming a true partnership.
I mean, just look at this timeline for a second. The acceleration is just staggering. In the 1980s, the foundations of reinforcement learning were just being laid out. By 2015, we had AlphaGo mastering Go. By 2025, AI is evolving code we can actually verify. And by 2026, we have these automated research toolkits emerging. From pure theory to automated discovery, all within a single generation. That's just wow.
And this creates a really interesting shift. The new bottleneck in science is no longer discovery, it's shifting to verification. You see, as AI gets better and better at generating new, creative solutions, the most critical human skill becomes validating them. The big question is moving away from how do we find the answer to, okay, how do we prove this AI's answer is actually correct and makes sense? So this leads to a whole new scientific workflow, a new kind of partnership. The human sets the direction, they come up with the hypothesis. Then the AI takes over for the discovery and execution, doing all that heavy lifting. And then it comes back to the human for verification and insight. And maybe the AI helps with the final report. It's this beautiful loop where each partner does what they do best.
You know, it really feels right to bring it back to the guys who started this whole journey, Richard Sutton and Andrew Barto. After winning the Turing Award for the work that laid the foundation for everything we've talked about, they said, the best is yet to come. Even they believe we are just scratching the surface.
And that really leaves us with a final, pretty provocative thought. As AI stops being just a tool and becomes a true partner in discovery, a creative collaborator, what's the next intractable problem we can solve together? What challenges that we once thought were completely impossible are now, suddenly, within our reach?